Hi everyone, welcome to our event. This event is brought to you by DataTalks.Club, which is a community of people who love data. We have weekly events, and this is one of such events. If you want to find out more about the events we have, please go to the description. There is a link to our events page, and you will see all the events we have in our pipeline. Very important, not to miss out, subscribe to our YouTube channel. So you will get to see events like this one today, conversations like this one today, and other fun ones. So yeah, don't forget to subscribe. And we have an amazing Slack community where you can hang out with other data enthusiasts. So the link for registration is also in the description. During today's interview, you can ask any question you want. There is a pinned link in the live chat. So click on this link, ask your question, and I will be covering these questions during the interview. And this is the usual introduction I have. Now it's over, and I will open the questions we prepared for you. Did you like the questions?
Yes. I actually didn't see there were questions until this morning, but
Okay.
It's a topic that I really like to talk about. So yeah, I was enthusiastic about them.
Okay, so hopefully it's not too surprising for you what you saw there. Okay, are you ready to start?
Yes, of course.
So this week we'll talk about data-centric AI, and we have a special guest today, Marysia. Marysia works as a lead data scientist at Go Data Driven. She has a strong interest in education and teaching, both as a part of her current role at Go Data Driven and also as a co-organizer of PyData Amsterdam and PyData Global. Welcome.
Yeah, nice. Thank you for having me.
The questions for today's interview were prepared by Johanna Bayer. Thanks, Johanna, for your help. So before we go into our main topic of data-centric AI, let's start with your background. Can you tell us about your career journey so far?
Yeah, sure. So I started by studying artificial intelligence at the University of Amsterdam. I did both a bachelor and a master in artificial intelligence. And my early career was focused on specifically applying deep learning on medical imaging, particularly early stage lung cancer detection in 3D CT scans. And within that domain, my focus was on geometric deep learning on the medical domain, which was also the topic of my master thesis, supervised by Max Welling. But after that, I transitioned into the role of data science educator at Go Data Driven, which meant that I taught and created courses on basically all things data science. And now I work as a lead data scientist at Go Data Driven. And in addition to that, I organize meetups and conferences, mostly in and around Amsterdam with PyData.
What did you do as data science indicator? You said your responsibilities included creating courses?
Yes.
That's cool.
Yeah. So at the Go Data Driven Academy, we teach a lot of courses on everything data science. So some are very generic, like an introduction to Python for data analysts or an introduction to data science, for instance. But we also create a lot of courses very specifically targeted towards a specific audience. So for instance, I created a deep learning with NLP course or an unsupervised learning course. And those are more detailed or more specific topics. And it gave me an opportunity to really dive into that topic and create good exercises and assignments and material on that. That was really fun.
Yeah, I think I spoke with folks from your company, from Go Data Driven, at the recent PyData PyCon in Berlin.
Mm-hmm.
And as far as I remember, you're doing education and consultancy, right? That's
Yes. Yes. So I was mostly a data science educator for about 2 years, but I strongly believe that you can't be a good teacher if you don't also have hands-on experience. So I like to really, when I do courses or when I teach courses, really tell a lot of anecdotes about my experiences and in my work, because it speaks more to the imagination of why we're doing this than just talking about the concepts. So while I really enjoyed it, I do feel like after 2 years mostly focusing on the educational side, I need some hands-on experience. And also I was really missing just the coding bit. So that's so the ideal situation for me is to do both trainings and education and also work as a data scientist and combine that in some way.
Do you still teach?
Occasionally some courses, but I'm more focused on my lead data science role at the moment.
Mm-hmm. And what do you do as a lead data scientist?
I'm with a company where I'm mostly focused on building a community of practice there. They just went through a transition in their the way that they organize their teams. And I want to make sure that all the data scientists still communicate clearly with each other, get to exchange knowledge, but also increase the maturity level of the data science products that we produce. So make sure that we are not just everyone doing something on their own time behind their own laptop, but bringing them together, make sure that we actually get to mature, well-functioning, monitored data science products.
Yeah, this is such an interesting topic, but I'm afraid I want to ask more about that. Maybe at the end, if we run out of questions,
Yeah,
because
sure.
the main topic for today is actually data-centric AI. And maybe it's related to what you do right now, building how you say, building a community of practice and improving maturity. So let's go back to data-centric AI. So what is data-centric AI? Why do we care about this?
Yeah, that's a good question. I did a whole talk at PyData London about answering this question. But basically, in short, the central idea behind data-centric AI is that the focus has to shift from big data to good data. So Andrew Ng said that having 50 thoughtfully engineered examples can be sufficient to explain to the neural network what you wanted to learn. And the reason why we call it data-centric AI is because it's in contrast to the model-centric approach that a lot of us are used to. Because in a model-centric AI, the focus is really on iterating on the model, which means that you create a baseline model given the data that you have, you evaluate the baseline, and then you go back to the model, you revisit the model in pipeline, and you make adjustments there. You change the algorithm, you adjust the architecture in your neural network, you tune hyperparameters, maybe even adjust some of the data transformations, such as how you impute missing values or augment your images. But the data is generally considered as, or the data set is generally considered as static. And the idea behind data-centric AI is that we shouldn't just iterate on the model, but we should iterate on the data as well. And that means improving the quality of our data by relabeling mislabeled or ambiguous data points, but it can also mean gathering more data or more examples of specific classes or readjusting the train and validation split. So data-centric AI is essentially about focusing on your data rather than just focusing on your model. And the idea of that is, of course, isn't new. I mean, I know that one of the first things that I was taught was garbage in, garbage out. So that's always been the idea. But the thing is that I think, or I strongly believe that data-centric AI is particularly relevant now than compared to, let's say, for example, 10 years ago. And it's like the hype around deep learning. Deep learning wasn't new in 2010, for instance. The ideas weren't new. Perceptron, we know about perceptron since the 50s. The backpropagation has been around since the 80s. Even the first convolutional networks were already around in the 90s. But somehow deep learning really came to prominence since, let's say, about 2010 onwards. And that's not because the ideas themselves were new, but because the ground had changed. So we had large annotated data sets available, GPUs that became available, which meant that deep learning gained more traction. And I believe that something similar is happening for data-centric AI. We've always known that data is important, but it's more important now for, I believe, two main reasons. First of all, because more and more problems are now being solved with deep learning, we are more often dealing with unstructured data rather than structured tabular data. So unstructured data like images or audio or text. And whereas for tabular data, it's easier to focus on the quality because you have descriptive statistics and you can easily create visualizations to investigate correlations between features. It's easier to explore your data, and it's also easier to get an idea of the data at hand before you start any modeling. So after some proper exploratory data analysis, focusing on good data quality is kind of a natural result of that. But this is remarkably more complicated when you get to unstructured data, because it's more difficult to get a good insight of the data that you have at hand with unstructured data. You can sample a few images, but do you know for sure that your data is good and representative? So because we're dealing with unstructured data now more than ever, we are more in need of tooling and techniques to help us out with that.
It's a bit counterintuitive to me, because now we have, I mean, that we need this data-centric AI now more than 10 years ago. Because it seems like 10 years ago, when we didn't have all these GPUs, we needed to be smart about how we approach things, right? And then it mattered like what kind of data we have. But now you just take I don't know, a cluster of GPUs, throw in more data, and like you sit back and wait till it magically becomes better. It doesn't work like that, does it?
No, unfortunately not. There's this persistent idea that, the quantity of the data will compensate for the quality. So if your data quality is not good, just gather 1,000 more examples and that's fine. But I think something really changed because we're more than ever making use of transfer learning. So if you have to train a neural network all the way from scratch, then yes, more data is probably a good way to go. But nowadays we have large foundation models, and we are mostly focused on fine-tuning those, because I, as like an individual data scientist, I don't have the resources to compete with something like GPT-3. So I fine-tune it to my own problems. And when you're fine-tuning, that's the situation where the model has already learned a lot about the structure of images, the structure of text, but you want to fine-tune it to your specific problem. So if in that situation you are giving it examples that aren't right, then it's basically fine-tuning on the wrong thing. And I think that's one of those cases where the data matters more, the quality of the data matters more. And it's also one of the cases where we as data scientists can have a bigger impact, because I'm not going to adjust the architecture or the parameters or the of a large model that is provided to me, a foundation model, but I know about my data, I know about my use case, and I can focus on the data more than I can focus on the model itself.
I'll try to recap everything you said, maybe not everything, but the main ideas. So we have two approaches, data-centric approach and model-centric approach. So in the model-centric approach, the data set is static, and you iterate on the model, maybe tune the model, change parameters, try different architectures, you make some adjustments. You might also do some feature engineering, right? But the data set, the images or the rows of your data set, they remain the same. In contrast to that, in data-centric approach, you change the data instead of changing the model, or in addition to changing the model. So you also look at the data, you see the bad examples, you see like the good examples, you see where you can improve the data. Instead of focusing on the model, you put more effort, more emphasis on the second part, on the data part, right?
Yep.
And I think that this model-centric approach is very typical for a Kaggle competition. So in a Kaggle competition,
exactly.
you have a train.csv file, right? And then you have test.csv file, and then that's all you got, right? And then you, of course, have some room for experiments. Like you can, I don't know, tune your XGBoost model. You can train as many models as possible. You can put all of them together in an ensemble, but then it's model-centric approach, right? Because you're tuning the knobs of the model. While in data-centric approach, it's different. And the reason I spoke about Kaggle, because I also heard that there are competitions about data-centric AI. And to my knowledge, you even took part in one of, or maybe multiple ones, one of them. So maybe can you tell us about these competitions?
Yeah, sure. So of course I took part in multiple Kaggle competitions, as many data scientists as well, but I really recognize what you're saying, that usually you have your data and you don't go about gathering more data, or it's more about the model itself. But as a contrast to that, we have the Data-centric AI competition that I participated in with two of my colleagues, Rens Dimmendaal and Roel Bertens. And the Data-centric AI competition was a competition hosted by deeplearning.ai that ran for 6 weeks in September 2021. And the central idea behind this competition was the model was fixed and the data could be changed. So the task was about classifying images of Roman numerals, handwritten Roman numerals. And we were initially provided with a data set of 3,000 images divided into a certain train and validation split. And it was up to us to submit the data, and all the compute was handled on the challenge side. So the model was a fixed ResNet 50, and we could submit up to 10,000 images. So there was a cap there. We couldn't just say, let's let's just get a huge quantity of data.
That's smart to add this limit, right? Because you can just
Yeah,
generate so many images and just overload the system with this.
exactly. So there was a cap on that. And one of the things that I really liked about that, besides, introducing me to this idea of data-centric AI, was that it made participating very accessible. It was a deep learning challenge because it was an image challenge, but you didn't need any beefy GPUs because all the compute was handled for you. So that means that anyone with about 10 MB of storage space and an internet connection could participate. And like I said, I participated with my colleagues Rens Dimmendaal and Roel Bertens, and we ended up winning in the most innovative category and presenting our solution at the Data-centric AI workshop at NeurIPS alongside the other winners.
That's really great. Was it your first exposure to this idea of data-centric AI?
Yeah, that's an interesting question. So it was my first exposure to the concept. So I'd not heard of data-centric AI before. But my one major competition that I participated in before was also a Kaggle competition. And that was the Data Science Bowl, where we participated in detecting whether someone had lung cancer or not based on CT images. And that wasn't a data-centric AI competition, but it turned out we ended up in third place, me with the company that I was with at the time. But it turned out that all the top 3 solutions, they really didn't use the data that was provided by Kaggle whatsoever. The second solution by Julian DeWitt was all focused on creating a system so he could easily evaluate whether the scans or the data that he had was any good and making selections based on that and creating a tool that allowed him to easily annotate additional information, which made it easier for him to get to that second place solution. So while that wasn't named as a data-centric AI competition, it was very interesting to me that we all the top solutions ignored the data that we were provided with and decided to focus on gathering additional data, creating a model in a completely different way based on the data that we did think was more useful. So it was kind of data-centric in that sense as well.
You just didn't know it was called data-centric.
Yeah, exactly.
It's pretty typical for Kaggle competitions, I think, to use external data. You'll have to disclose that you use this particular data set, right? But I guess it gives you an edge in image competitions when there is an external data set that you can use to make your model better.
Yeah, I agree with that, but I also think that there's a difference between simply gathering more data and, for instance, what some of the winning approaches were based on, focusing on finding out what the most useful data to add was, like what things were we missing in our data, what things weren't we missing, which examples had to have a higher weight because they were more important than other data samples. Those kinds of decisions about your data, which I think goes a bit further than just getting some extra images.
This is a nice answer to a question: why should I take part in data science competitions? Right? Then you might stumble into an idea, and then for you said it was September 2021, not so long ago, but now you are giving talks about data-centric AI. You're talking on podcasts about that. So I guess your life, and then you also won this most innovative approach award, right? So I guess your life changed a little bit after taking part in that competition.
I think data-centric AI for me is, when we talk about something like this, it's very often focused on the tools and the methods. Like, how do we do something like this? What kind of packages do you use? What kind of tools? But for me, the most important thing was a mindset shift. Focusing on the data and not seeing the data sets as static has really helped me throughout my career since that moment, because I think that's a very important insight. That yes, this may be the data that I have, but I can also make decisions about that and change it throughout my modeling process.
Yeah, that's interesting. The point about changing. So earlier today, you mentioned that your train validation split is also, it doesn't have to be static. Right.
Yes.
And then immediately to me, like I thought, but wait, if our validation set is not static, how do we compare two approaches and say that this approach is better than this one if our validation set is inconsistent, if we change it between two runs? You see what I mean, right? So like you have let's say, two models, right? And then usually the easiest way to compare these two models is to evaluate these models on the same validation data set, and whatever model gets higher score is better, right? But the moment we change validation data set, we cannot compare these models because they are evaluated on different data sets, right? And for me, it got me thinking, like, okay, like now if we start changing the validation data set, how can we be sure that it's actually an improvement?
I think that's a very valid question. First of all, when we were participating in the data-centric AI competition, I think that our insight that the train and validation split that we were provided with wasn't, for us, a good split. Our validation set turned out to be not very representative of all of the data. There was a huge part of the data that was not represented in the validation set that was represented in the train set, so we decided to rebalance that. In our case, in the data-centric AI competition, we didn't have access to an actual test set because that was handled on the competition side. So there was another holdout set that we were eventually evaluated on. And the validation set in this case was used in order to determine when we were done training. So the for early stopping was when it was used. So in that sense, it still matters. I do believe that I have a very technical artificial intelligence. I like to focus on the numbers type of background, but I do also believe that we shouldn't only focus on the number of the metric. Sometimes you can make a change to your test set, to your validation set, which makes the numbers go down, but gives you more confidence that that number is correct. If you notice that, for instance, your test set or your validation set, the thing that you eventually validate on, is missing a part of the data that you do expect to encounter in practice, do you not add that data to your test set because it's no longer able to compare the models? Do you not add it because your metric will go down? I think it's better to change it, but be confident about the change that you have made. That makes it more trustworthy what your eventual result will be.
Then at the end, you can just re-evaluate all this. I know we're talking about data-centric approach, not model-centric, but then at the end, if you change your validation data set, you can just re-evaluate your approaches on the new split, on the new validation.
Exactly. Yeah, I think I also want to emphasize, of course, that data-centric AI doesn't mean that we shouldn't change the model. I think it's often named in contrast to model-centric AI, but for me, data-centric AI means that we iterate on both the model and the data. So yes, doesn't mean that I just take a baseline and never change my model anymore, because in practice that won't get me the best results. But I do think there's very often there's more to get from improvements on the data than, for instance, change the entropy in your decision tree to a genie, for instance.
Yeah, right. Well, you said for you, the most important realization was to the mindset shift from not just how we do this, but also that, data set is not a static thing. You can change it. But I'm still wondering, how do we actually do this? Like, what are the tools? What are the approaches for that? How do we implement this?
Yeah, that's a very good question. So there's not one toolbox that I can recommend that has everything. I think it's a very broad subject. It's also what you like to focus on. There's a lot of tools out there that can help you with labeling, or finding the data points in your data that need labeling. But of course, there's different tools for text-based or image-based or audio-based. But there's way more to data-centric AI than just relabeling. There are also tools for instance, generating synthetic data, and how do you create good synthetic data to augment your current data set. So there's a very broad spectrum of things that are all data related. And there's also a lot of development at the moment being done on these tools, because I think that at the moment we all experience, especially working with foundation models, working with unstructured data, we experience a need for tools that help us out with these kinds of things. So a lot is currently being developed. A lot of high-tech tools, a lot of low-tech tools as well. I'm personally a big fan of not using one thing and having everything work out of the box. I wouldn't like a magic fix all your bad labels tool that if there would be one, because I think that I have my value as a data scientist is in understanding the data and talking with subject matter experts. So I like to have a lot of control over that process. And I think the most important lesson that we learned is that at the end, it's not about what tools you use. It's about how easy you make it for yourself to iterate on the data and how you keep track of that. So that could mean that you use DVC to version your data and you have a good overview of all the data sets that you've used. But in our case, for the Data-centric AI competition, we were still naming things with underscore version 3, which maybe wasn't the nicest versioning approach, but it was easy for us to relabel our data. And that was a very important thing. That wasn't a bottleneck.
Yeah, funny that you mentioned the approach for data versioning that you had. In DataTalks.Club, we recently launched a competition, and this competition is about predicting, not detecting, determining, classifying images of different kind of kitchen stuff. Like it's a plate, cup, glass, fork,
I think
spoon,
I saw that.
and so
Yes.
on. Yeah. And for me, like I was preparing the data for this competition, and the folder that I ended up with, the name was like new to Kaggle final something.
Yeah, I think we've all been
that
there.
was terrible. Yeah, I wish like maybe for the next one I'll use something like one of these tools that you mentioned, like DVC or something else, because it was like very hard to keep track at the end, like what was changed between like these thousands of folders.
Yeah, it's the same thing when I started out as a data scientist. When I was trying out different hyperparameters, I would be writing things on a post-it note next to my laptop, and there's a better way to track your experiments than just writing everything on a post-it note. I think the same goes for your data, probably. So yeah, that's versioning, but also just changing your data. I think that's an important thing. For a lot of people, it's difficult to do because there's a whole, it's considered static. So one of the things that made it really easy for us during the Data-centric AI competition is that we basically started labeling in Google Docs. We found out that when you have the URL of an image, you see the image itself. So we could very easily change it, change the label that was associated with it, and then turn it back into a pandas data frame, and then do some magic scripts so that every file would be in the right folder. And it took a bit of time to create those scripts, but it made all of the other work a lot easier for us in the long run to adjust things. And I think that's an important one. Make it easy to make adjustments.
So the process you had a Google spreadsheet with one column, I guess, URL, another column class, right? And then you could just go there and change a label there or multiple labels. And then you had a script that would pull data from this Google spreadsheet and train a model. And then it would say, okay, like
exactly.
For this version of the spreadsheet, this is the score you have.
Yeah, exactly. We also had some little tricks to make it easier for us to work with the spreadsheet because, again, there were 3,000 images. So that means that you have 3,000 rows. So we did things like, which was relatively easy to do, put the data through a model, already get some predictions, and then order the data points on confidence of the model, for instance. Or we made extensive use of the embeddings, visualizing the embeddings and seeing that some data points were very far away from the distribution of that class. And then that's one of those data points that you pay attention to. So we made use of little tricks like that to filter on what to focus our attention on.
And I recently had a chat with one of your friends, PyData colleagues, Vincent Parmadam. And I think he's really into these tools that help you with finding bad data, right?
Yes, that's true. He actually did a talk in PyData Eindhoven last week on bulk labeling with a lot of tricks, which was a really good talk that I recommend.
No. So maybe you said like the most important thing is focusing on the approach, how you iterate over this, and how you make it easier for you to iterate, rather not instead of focusing on high-tech and low-tech tools. So I guess the low-tech tool that you used in your competition was this Google spreadsheets,
yes.
right? But I'm really curious about the approach that you took. Like, how would you actually implement this in practice? How would you, let's say you join an organization as a consultant or maybe as a data scientist, in-house data scientist, and you want to follow this data-centric AI approach. how would you structure your project? What kind of tools would you use to make it easy to implement all of the things we discussed?
That's a good question. I don't think I have a specific answer on what tools I would use, but that's, I think, mostly because I don't feel strongly about certain tools over others. I'm more interested in the process. I think one of the most important changes that I would make, and I have made in the organization that I'm with, is that one of the most important lessons that I learned from the Data-centric AI competition is that data is more easy to talk about than the model is. It's very hard to go to subject matter experts and talk about your results and say, well, I used weight normalization instead of batch normalization. That's not a very viable conversation. But you can show examples of the data. You can talk about the data. You can talk about the odd examples that you find and go to someone who knows more about the source of the data that can explain things to you. And I think this was particularly relevant when I worked in a medical imaging company where we actually had a doctor employed who, whenever I found odd things in the data, I could go and talk to him and show him, and he would explain things to me, and that would really adjust the way that I approach the modeling as well. So I wouldn't have any specific tools to recommend, but I would recommend having a very close connection to the person who knows more about the data, and realize that when you focus on change, if you get the same performance, but changing the data or by changing the model, by changing the data, it's much easier to collaborate. And it's also much easier for the person who you're presenting the model or the end result to have a bit of faith that it's working correctly rather than just an abstract metric.
I guess what I wanted to hear from you was more, how to say, tactical. Like for me, what you say sounds like strategy. Okay, you need to be close with subject matter experts, which is super valid. But I'm still wondering, like, how do I actually make it happen? So I have a project, I have a bunch of subject matter experts, and then I have a data set. And I want to make sure that I don't go crazy. I don't have like 1,000 folders with names like new version 2, Kaggle final, new, and so on. Like, how do I make it happen? Like, how do I organize this? Do you have like any tips on tricks or best practices, or I don't know, talks that I should check or anything like that?
Yeah, there's actually okay. The reason why I find it very difficult to give an answer to this is because I think there's a lot of great tools out there. But there's two resources. There's two resources that I find very useful. One is by Hazy Research and one is by Data. They have a really good overview of awesome AI, data-centric AI tools that are structured in the way, is it about profiling? Is it about synthetic data? Is it about are you working with images? Are you working with text? Because the tools are very specific to that. So those are two resources that I would recommend to look for the right tools for the use case that you're working with. And I would, as a data scientist, still start with the model-centric approach. I would still create a baseline as a model, but then use those model results to not only go back to the model and how to adjust those hyperparameters, but also use the results of that to see if there's any gaps in my data that I'm seeing.
So it's basically doing error analysis and understanding where the model was wrong, and then trying to understand why the model was wrong, and but talk to people who know data well to figure this out, because maybe for you alone it could be difficult to understand why for this particular data set this was the final label, or this was the predictions, right? So maybe it helps to talk to a subject matter expert to figure this out, and maybe conclude that maybe the label on this example is actually not right and it should be a different one. Okay.
Exactly.
So this is how the process looks like, right? So you train a model, you analyze the errors, you analyze the mistakes of the model, you talk to subject matter experts, and you iterate until the model is good enough.
Yeah, basically.
Okay, sounds simpler than I thought.
I think it's always important in these kinds of things to keep humans in the loop, and that could be subject matter experts, but that could also be just the data scientists who's learned obviously a lot about the data as well and knows what they're doing. I'm not a big fan of the type of tools that automate everything away. I know there's a lot of optimization going on that can really help us, but always keep a human in the loop to be sure that you can truly trust your results.
But I must admit, it sounds terribly similar to standard data cleaning. Like you have errors, then you go to the data set and you see, okay, this row doesn't make sense. This is an outlier. I just throw it away. And then maybe you even have a rule that, okay, if like this value in this feature in this column is like 2 sigmas away from the mean, then you just throw it away or you add it or whatever, which is a pretty standard data cleaning step, probably. Like, what's the difference between these two approaches? Or the data cleaning is data-centric AI?
I think data cleaning is a part of data-centric AI, but data-centric AI itself is more broad. It's easiest, I guess, to talk about data-centric AI in the terms of what is a good label and what is a bad label, or how do you choose to deal with your missing values. But it's a lot broader than that. It's also, for instance, about what I think is a very important thing, is my data set representative, and is there any bias in that? Is my data set complete? And those are not things that are typically part of data cleaning. And there are tools being developed, for instance, for images, to see if you have a representative data set, if you have a complete data set, and those tools can really help there as well.
How do we actually check that? I'm really curious. Like, I have a data set now with spoons, forks, cups, glasses. Like, how do I know if it's complete?
Yes, that's a good question. I think it's very hard to know if you just without any domain knowledge. So, for example, one of the approaches that a toy project that I did once was classifying penguin species based on images, and I sourced the data set basically just through downloading all the Google image results. And of course, lots of the data is right. There's a few mistakes in there, and it was easy to focus on getting those bad labels out of there and relabeling those. But I think that's one of those cases where it's very easy to I mean, if there's one penguin classified wrong, maybe we can gather a bit more data, and that kind of compensates for that, right? But to make sure that it was representative, in that particular case, I thought about what situations are there where I can encounter penguins. Like, they can be on land, they can be in the snow, but they can also be on water, for instance. And I need to have groups of penguins, and I need to have individual penguins, and I need to have penguins from the side, and maybe not necessarily from the top, but all the things that I can encounter. And I noticed just by going through my data that I was missing a lot. I didn't have a lot of example of baby penguins for the different species, for instance. So that was one of those examples where my data set was not complete. And of course, this is something that I could have figured out by just scrolling through all the images and noticing this. But in this particular case, I came up with the different things that I thought I should have in my images. And I decided to visualize the embeddings of my images. So I basically put my data through a neural network that was already trained, then didn't take the head of it, but I took the embeddings and I reduced the dimensionality to UMAP. With UMAP, so I could visualize it. And I used an interactive tool to be able to view my images. And I saw different clusters of types of images, because of course, all the penguins in the water were kind of together in terms of embeddings, and all the penguins on land were kind of together. And I used that interactive tool to get a bigger insight in my data. And then I noticed, yes, I did see a few baby penguins, but I didn't see a lot of data points around those. There were only 3 in my data set. And I think that's one of those cases where it's part of my data gathering process, but I did think about this up front. I didn't think about what kind of penguins can I encounter, and do I see these in my data set? And I didn't want to manually go through the images because that would take a lot of time. So I used like kind of a neat little trick of visualizing the embeddings to make that process easier for myself. And then I gathered more data by Googling the type of penguin and then the word baby after it. And that's how I gathered more data in the right category.
And I think one of the tools that we can potentially use is a tool from Vincent, which is called Embedder. Right? Just 1 second. My kid needs to check that there is a package, like a postman came, and he needs to see. Okay.
Yeah, that's really cool. I actually did this project before I knew about Embedder, so I would really like to try it out again, whether that makes my life a bit easier.
Yeah, for anyone who is watching this right now or listening to this, there is a video from Vincent in our channel. It was published, I think, this week. It's called Open Source Spotlight, Embedder, and Bulk. So Vincent showed 2 tools. Yeah, that's. I'm really amazed by how he like turning his ideas into these small little projects and then just publishes them in open source. So yeah, so the approach for you is you need to think about all the situations where it's possible to encounter a penguin, or like if we generalize, all the contexts, all the situations where we can see like the objects we're detecting, we're understanding, and then see if we miss anything. Like for example, if I go back to this data set with cups and glasses, perhaps I need to think about the conditions, like the light conditions, for example. Like, I need to have images that are well lit, when it's dark, when it's bright, right? And then different angles. Like sometimes maybe in some situations I see the handle of a cup, in some situations I don't, right? And then I need to, like, from different cups from different angles and so on. Then, okay, so it's just sitting and thinking, maybe taking notes, right?
Yeah, and I think it's important that you do this at the start of your process when you first gather the data, but this can also be part of your error analysis. When you see that your model is specifically making mistakes on cups where you can't see the handle, that might be a reason for you to think, okay, maybe I need to gather a bit more of that data. And verify that hypothesis. So that's a hypothesis that you can make. Why is my model having trouble with this particular image? Verify that with your initial data source, see if you can gather more data, and then have a new version of your data set and try, let's say, exactly the same model again and see if it works better now.
And when do we stop? Like, how do we know if it's good enough?
I think that's always a very difficult question in data science.
It depends, right?
It depends. When your results are good enough for your use case, why you're doing this, and how much time you have. It also matters. For instance, it was for me when I was doing the Penguin project, because I was just sourcing images through Google. It was very easy to just Google baby penguins, Adelie penguins. That was very easy to gather more data. But if you have to actually go out back to your kitchen and photograph a bunch of additional pictures of all your cups, that does make it a little bit more complicated. So it's also, when is it good enough? If given the time that you have and given the project that you have, your results are satisfactory. And that can be because of model tuning, but that can also be because of data tuning.
And then I guess talk to subject matter experts, stakeholders, and ask them what they think. Like, is this, I don't know, 80% accuracy is satisfiable, or they need more?
Yeah, though in my experience, that's also always a very difficult conversation to have, because when you just talk about metrics, lots of people it's just a random number. 80% sounds nice. Highest number is best. I think it's always, so that's always a very difficult conversation in my experience to have. But you can give examples of your data as well. Like, these are the data points that it classifies correctly, and these are the ones that it still has some troubles with. Is that okay for you?
Okay. So I think you've been advocating for this entire interview. Don't focus on metrics, right? Focus on data.
Yeah, I guess so. Yes.
So it means like, okay, like if I know that my model is making mistakes when it's dark, like there is not enough light, I can just talk to my stakeholders and show, okay, there's a picture of a fork, but the lights are turned off. That's why the model thinks it's I don't know, a glass, right? Are you okay with this? Or we need to collect enough pictures of forks in complete darkness, then the model will be better. Okay,
yeah,
so
exactly.
This is the approach you would take. Okay, cool, interesting.
I think that's also because of my background in the medical field, where we were doing deep learning, but explainability was very important, because trust in the system was a very important thing. And you don't gain trust by just showing a graph or showing a metric.
And then another thing it occurred to me while we were talking is that we can take a simple model, and if our conditions allow, maybe for medical field it's not good, but if it's a simple, I don't know, think classification, we can just deploy our model and see how users play with this and collect feedback from the users, right? So let's say if we want to deploy, there was a project I did a couple of years ago. It was about classifying garbage types. Like in Europe, in many countries, like garbage of certain type needs to go to a bin of certain type, right? Like you put plastic in Germany, you put plastic in a yellow bin, and you put paper in a blue bin. I don't know how it is in the Netherlands. Probably something similar.
Yeah, I heard the municipality of Amsterdam is doing a very similar project where they send out cars to notice the garbage on the street and notify the right people to pick that up.
Yeah. So, and then you have this model, and then you can, I don't know, just create an app, and then see what kind of things users send. And see if there are any mistakes there. Like, for example, if the model says that paper should go to like the black bin, which is for everything else that doesn't fit the other bins, like maybe you can understand, okay, you can try to understand why the model is making these mistakes. What kind of things are we missing? And is it because like our data set is wrong or because our model is not so good? How can we fix this problem? And then probably the reason for that is data, right? And then we collect
very often it is. Yeah.
Very often it is.
Very often it is.
Do you think
I think it's important.
Sorry.
Yeah, I think it's important. I think an important part of data-centric AI is focusing on the data. It's also about how do you actually label your data? How do you know that it's good? Exactly what you just said. Collecting user feedback can be a very, very good way to get more knowledge about the data that you have.
Is it a typical approach how we put this in production, or like maybe there are other approaches? We just roll it out and see how users react? Because I guess if we talk about medical field, we cannot just deploy this model to I don't know, lung cancer things, right? And then let people just use it and correct data later. That's simply not applicable. There we need to use a different approach. While in case of garbage classification, it's okay if one piece of paper will end up in the wrong bin.
Yeah, so that's actually interesting because we did do this with the medical imaging software. We actually did deploy it in hospitals, and but of course, not very broadly. At first, with a few people who were interested, and these radiologists volunteered to have our software run next to their day-to-day job. So they were still end responsible for judging the scans. The software was not making any decisions. I think that's a very important thing when you're still developing. But they did see the model results of the software, and we talked to them extensively about the feedback. So we got a lot of feedback, for instance, that certain mistakes were being made or certain types of mistakes were being made. And that at that point already led us to gather more data of those kinds of examples.
I think it's called shadow mode deployment or something like that. So you deploy this thing in addition to whatever process is there, and then you just use this to collect data, and then you compare whatever decision the model is making with the decision of the subject matter expert, in this case a doctor, right? And then you see the where the model is wrong and where it's right.
Yeah, exactly.
I think we used something like that for moderation. So where I work at OLX, it's online classifieds. This is like a place for selling second-hand stuff. I think in the Netherlands you have Marktplaats.
Yes.
Yeah.
Yes,
so similar to that. And then in one of the projects, we just let it run in parallel to moderators, and then we compared the output of moderators with the output of the model, and we concluded that the model is good enough. Or like there were of course some issues, but then after 1 or 2 iterations, we concluded it's good enough. Yeah, interesting. I was asking you about that, like how do you know if it's good enough? But for us, it was talking to these moderators and thinking, okay, like do you think it will help you or not?
Yeah, and then I think that's the question that you need to answer eventually. Do you think this is a help?
And after that, we just rolled it out. I guess it summarizes pretty well what we've been discussing so far, right?
Yeah, I think so too.
What if we have a lot of bad data? Like, what do we do? And it's maybe not so easy to collect new data.
That's just a very difficult situation. If you have a lot of bad data and you can't collect new good data and you can't relabel the data, I guess you could do a lot of manual work to make your bad data a little bit less bad. But it's the same if you don't have enough data, then some problems just aren't solvable. I was talking at some point to someone who offered me a project who said, Yeah, also I want you to classify 13 different classes, but I have 54 examples. And also it's in 3D, it's 3D images. That's just not going to work. So unfortunately, there's not a clear-cut answer there. If you have a lot of bad data, it might require a lot of manual work to make it good data, but maybe if you don't have enough, it's unfortunately not a feasible project.
Okay. So you might even need to open your favorite image editor and edit some of the data, right?
Maybe, but I wouldn't be very enthusiastic about the project if that's what I ended up doing.
Okay.
I studied artificial intelligence because I find this whole topic, this whole field very interesting. And I do try to automate those things away, because if I end up just doing data cleaning by opening image editors and removing stuff there, I don't think that's the reason I got into this job in the first place.
So maybe it's better to have a model that is doing the editing, right?
That would be really nice, yes. Or tools that can help you out to automate a lot of this stuff away.
But then if it's just 50 images, then maybe you cannot really do this.
Maybe not.
Okay, another topic I wanted to talk to you about was your role with PyData. So I know that outside of your work, you're quite involved in the PyData community. So you are the co-chair of PyData Amsterdam. And in general, you're quite active. As I said at the beginning, I think I came across your talk in PyData Berlin this year, and this is how we decided to reach out to you. Was it this year? I think I found you there.
I spoke at PyData Berlin twice. And
okay.
I think I did a tutorial this year.
Yeah. What was the tutorial about?
It was called Serious Time for Time Series. It's time to take time series seriously.
Okay, I do remember seeing
quite a mouthful.
Like yeah. So what's your role there? What do you do in the PyData community apart from giving tutorials and talks?
Yes. So I joined PyData Amsterdam in 2019, I believe. And my role here is I basically joined it because I enjoyed going to meetups. So I studied artificial intelligence. I was focused on this very specific topic, deep learning for medical imaging. I'm just interested in everything about the field. So I really enjoyed going to meetups and learning more about experiences of others in the field as well. And by joining the committee, I was able to organize this as well. We organize a monthly meetup and we organize a yearly conference. So I've organized a conference for PyData Amsterdam. I've organized an online PyData festival for PyData Amsterdam. And I've organized PyData Global last year. And this year we'll full on back on organizing PyData Amsterdam and making sure that we can create a really cool conference that brings together users and developers of basically open source packages in the data science ecosystem. A confusion that a lot of people have about PyData. I know that the name is maybe a bit confusing. It's not just about Python, it's also for Julia and R users.
Yeah, it is confusing, I must admit. Maybe it started as a Python conference, right?
Yeah, I think so too.
You said that in 2019 you joined the committee, but I don't think it happened like one day you woke up and you then walked in the committee and said, okay, do you mind if I join you? It was something else, right? Like how did it look like? How did it happen that you joined them?
I think it was actually 2018, come to think of it. But basically, I was attending a couple of meetups, and at some point, the committee is on stage, and they said it was actually Vincent who said on stage, "Hey, is there anyone who would like to join the committee? In the break, come talk to me." And that's I like organizing these kinds of things because I like to. When you organize it, you have the luxury of also determining what you organize. So I get to organize the meetups that I like to attend and the conference that I'd like to attend. So I decided to volunteer. And that's also how we got our entire new committee. We have about 16 people in our committee at the moment to organize the conference, and all of them joined basically because we just did a shout out at a meetup. Like, do you enjoy this kind of thing? Do you want to help shape this? Come and join us.
Yeah, I guess it's pretty useful to have a community, and then you just say, okay, like, does anyone want to help us? And there are a few people who want, and then so this whole process didn't sound like it took a lot of time for you to actually, from the moment you started attending meetups to the moment you joined the committee.
No, that wasn't a long time, I think. Don't remember when I first started joining meetups, but
Okay. Well, I guess when you live in Amsterdam, that there are so many meetups and communities, then it's just easy to
Yeah,
be a part of one.
I think that's one of the reasons why I really enjoyed helping out with PyData Global as well, because I realized I'm very privileged. I live in Amsterdam. One of the reasons why I attended a lot of meetups was because they were simply very close to my house. So if I didn't enjoy it, I could just go home. And that's really nice about the city that I'm in. But of course, a lot of people live in places where it's not as easy to attend meetups and therefore share that knowledge and gather that knowledge. So that's what I really like about PyData Global. I personally do enjoy in-person meetups and conferences more, but I do think it's very important to make all of this information as accessible as possible. And that's the idea behind Global, that it's for everyone all over the world. Anyone can join. And that's why I like helping out there.
I guess it started as in response to the pandemic, right? So people
Yes,
couldn't just go to in-person meetups, but then in addition to being able to connect during pandemic, it also allowed people from any part of the world to join and to also take, like if somebody does not live in Berlin or Amsterdam or New York or any other big tech hub, then they can just connect to PyData Global from their village and take part in this, right?
exactly.
Cool. And what's the difference between PyData and PyCon?
Yeah, so I think the major difference is that PyCon is for everything Python, and PyData, besides also Julia and R. I'm not sure how PyCon feels about that, but our focus is more on the data side of it. So PyData is actually the educational flag of NumFocus, and all the proceeds of the conference that we organize go to support the open source ecosystem, but specifically the packages that I, as a data scientist, use a lot, like NumPy, Matplotlib, Pandas, scikit-learn, those kinds of packages. And that's also what you'll see that most of the talks are about. Whereas PyCon, I would say, is generally a little bit broader than just data science and data analytics.
I still think there is some bias towards Python tools in PyData. I don't,
Yes,
just
I
historical
agree.
reasons, right?
Yeah, we have to make a conscious effort to make sure that the R and Julia folks feel included as well. I am mostly a Python user. I started with Java, Matplotlib, or Java and MATLAB, and then switched to Python. I've only played around with Julia and R, but I think most of these things, most of these talks aren't really about the tools or about the language or about the code. It's more about the concept. So I think that translates well into other languages as well.
Yeah, I remember one of the talks in PyData Berlin this year was like it was a general approach from a company who is selling cars, similar to what we at OLX do. That's why it was very interesting for me to check what competitors are doing, and they use Java, for example, which is not any of these three languages, but yet the talk was quite nice.
Yeah.
Maybe you should rename it to something like, like how IPython notebooks got renamed to Jupyter.
Mm-hmm.
So maybe
Julia
it should,
R and Python. That's what
yeah,
Jupyter is for. Yeah.
yeah. So maybe it should be Jupyter data instead of PyData.
Yeah, maybe, but I'm very involved with the Amsterdam chapter, but I think there's like more than 100 chapters. I don't think I have the authority to change all of those names.
Yeah, probably not going to happen, right?
Maybe not. No.
Okay. Well, I think the one last thing I wanted to ask you is how can people find you if they have any questions?
Oh yeah, that's a that's a good question. I always really like it when people reach out. So I'm reachable through LinkedIn. I have my website, which is marysia.nl. So just my first name .nl for the Netherlands, and my email address is on there as well. So feel absolutely free to reach out. Also, if you want to get involved with PyData, maybe speak or maybe get some tips there, or talk about data-centric AI. Be really happy to talk about those topics.
Okay, thanks a lot for joining us today. Thanks everyone for attending too. And yeah, it's Friday today, so have a great rest of the week and have a nice weekend.